Good day, everyone. Today, we will be discussing Module 7, Facility and Location Layout under Operations Management. Let us start with our topic, Facility and Location Layout. This module focuses on two main ideas, where a business should be located and how its internal space should be arranged. Both decisions are very important because they affect efficiency, cost, productivity, and customer satisfaction. Next, let's look at the objectives of this module. At the end of this lesson, we should be able to explain the concept of facility location, discuss the factors that affect location decisions, explain the procedures and techniques used in selecting a facility location, understanding the concept of facility layout, list the types of facility layouts, and describe service facility layouts. These objectives guide us in understanding how business plan both their physical location and internal arrangement. Now, let's move on to the objectives of facility layout. A facility layout problem can have many goals. In manufacturing plants, the most common objective is to minimize materials like handling costs. This means reducing the movement of materials from one area to another to save time, effort, and money. When materials move less, the production process becomes faster and more efficient. Aside from minimizing materials handling costs, another important objective is the efficient use of space and labor. This means arranging the machines, equipment, work areas in a way that maximizes available space and ensures workers can perform their tasks effectively without congestion or delays. Next, we further explain the objective of facility layout. First, it aims to eliminate bottlenecks and waste or unnecessary movement. Bottlenecks slow down operations, so removing them helps improve productivity. It also facilitates better organizational structure, communication, and interaction between workers. A good layout supports the manufacturing process and allows easier visual control of operations. Another objective is to minimize manufacturing cycle time or customer flow time. This means reducing the time it takes to produce a product or serve a customer. It also aims to minimize investment costs while still maintaining efficiency. Lastly, a good facility layout should provide convenience, safety, and comfort for employees. It should be flexible enough to adapt changes such as increased demands or new technologies.
Facility locations refers to the decision of where a business or service facility should be placed. This is an important strategy choice because the location affects how well an organization can serve its customers and meet future demand. A good facility location can improve competitiveness, while a poor one may increase costs in transportation, labor, and in operations. In service industries, convenience for customers is especially vital since the facility must not only produce goods but also deliver services directly to people. Location factors, which are the key considerations when choosing the facility locations. One major factor is proximity to customers, because being closer makes it easier and faster to serve them. Another factor is proximity to suppliers, which help reduce delivery time and transportation expenses for raw materials. Lastly, proximity to labor. It is important because business needs access to skilled workers, and labor availability and cost in influence and success in operations. Layout design, particularly the layout process. A process layout is a type of facility arrangement where several resources, equipment, and activities are grouped together. This layout is commonly used when a company offers a wide variety of products or services. Since it provides flexibility, customers and or productions move through different departments depending on their specific needs, making it suitable for service operations and customized work.
One advantage is that service systems they allow a wide variety of routes that may be chosen by customers depending on their needs. Another advantage is that the product or service range may be extended, and as long as no new resources are required, may be accommodated within the current layout. Product layouts, also termed line layouts, arrange the resources required for a product or service around the needs of the product or service. In manufacturing applications such as assembly lines, with a high volume of a standard product that the products will move on in a flow from one processing station to the next. In contrast to the process layout in which products move their resources, here the resources are arranged and dedicated to a particular product or service. The term product layout refers to the arrangement of the resources around the product or service. In services, the requirement of a specific group of customers are identified and resources set up sequentially. So the customers flow through the system, moving from one stage to another until the service is complete. A key issue in the product layouts is that the stages in the assembly line or the flow line must be balanced. This means that the time spent by components or customers should approximately be the same for each stage. Otherwise, queues will occur at the slowest stage. The product or line layout is an efficient delivery system in that the use of dedicated equipment in a balanced line will allow a much more faster throughput time than a process layout. A hybrid layout attempts to combine the efficiency of a product layout with the flexibility of the process layout. Hybrid layouts are created from placing together resources, which serve as a subset of the total range of products or services. When grouping products or services together in this way, the grouping is termed a family. The process of grouping the products or services to create a family is termed group technology.
Mabuhay! I will discuss about the line balancing. Line balancing is a critical aspect of designing efficient product layouts, especially in manufacturing or assembly environments. It involves optimizing the allocation of tasks to workstations to achieve the desired production rate with the fewest possible bottle racks or idle time. The goal is to distribute the workload as evenly as possible among workstations, ensuring a smooth and continuous flow of production. Here's a breakdown of key concepts and steps in balancing. Number 1 is task and precedence. Number 2 is the cycle time. Number 3, workstation allocation. Number 4, balancing metrics. Balancing metrics involves the idle time, efficiency, and smooth index. The benefits of effective inline balancing, it increases productivity, reduce cost, improve workflow, reduce work in process or WIP, and last, better employee morale. In summary, line balancing is about creating a harmonious and efficient production where each step is optimized to contribute to the overall speed and effectiveness of the manufacturing process. It is a crucial tool for any organization looking to maximize the production capabilities and minimize waste.